In these next couple of examples that we're going to work through in section 10.2, we are going to look at our simple interest and our future payoff. So the first one, we are going to kind of work through example 3 twice using two different methods and kind of show how we can use them. And then we're going to do one in example 4 where we're just going to use our future payoff formula. As you're going through this chapter, there's going to be multiple different times where I might say, well, yeah, we could do this one of many different ways as far as doing our calculations and showing our work. How you may choose to work through every step might be slightly different than the way I did, but either way, we should be ending up with the same result in the end. All right, so in example 3, use our simple interest and future payoff formulas to find the following. Sherry needs to borrow $6,200 to replace the roof on her home. From her credit union, Sherry obtains a 30-month loan with an annual simple interest rate of 5.75%. Determine the amount Sherry will pay the credit union at the end of the 30 months to pay off her loan. So the difference is we're not just looking for the interest, right? We are looking for the payoff, right? We're looking for what she needs to pay off her loan at the end. All right, I'm still going to start the same way I did in the previous examples. I'm going to start by listing off my different pieces of my formula. Again, my formula, I equals P times R times T. Right, so our P is the 6,200 that needs to be borrowed. Our R, our interest rate, 5.75%, so 0.0575. Our time, notice that our time is given to us in months, right? So we have 30 months and we're going to divide it by 12 months in a year. So in this particular example, right, our time is given to us in months. We can leave that as a fraction. You can write that as a decimal. It's kind of up to you. I'm just going to leave it as a fraction as I go through here. All right, so to find our interest, we're going to take 6,200 times 0.0575 times 30 over 12. Again, as you're plugging stuff into your calculator, it's up to you kind of however you want to do this. Whether you use a scientific calculator or a graphing calculator, you can use parentheses, you can type this in as a fraction, we could change it to a decimal over here and plug the decimal in, whatever you're most comfortable with. Right, so when we plug these into a calculator and we multiply these all out, we get 891.25. So that's our amount of interest. Right, but remember, going back to our original question, we weren't asked about interest, we were asked about how much they need to pay off. Right? So our future payoff, we take our principal and we add our interest to that. Right? So if we take our original loan of 6,200, add our 891.25 that we just found for interest, then we have a future payoff of $7,091.25. So that's one way we can find our future payoff. Right. We do have another alternate way. Remember, on the previous page of our notes, we did have a couple of different formulas for our future payoff formula. So one of our future payoff formulas, we had F equals P times 1 plus RT. It's still going to be the same amount of information and the same things that we're going to plug in. It's just going to work through a little bit differently. Right, so our P is still 6,200. Right, our R is still 0.0575. Our T is still 30 over 12. Again, we can just go ahead and leave it as a fraction as we're going through. If you really wanted to, right, we could switch it to a decimal. Gives us 2.5. If for whatever reason the decimal doesn't work out nicely, we don't want to do too much rounding in the middle, so sometimes leaving it as fractions could be the needed thing to do, but just kind of keep in mind that that is one option. I'm just going to leave everything as fractions though, so I'm not going to worry about that division, but I did just kind of want to mention it as a possibility if that's something that you want to consider. All right, so we're going to plug all of this in. We're going to do 6,200 in parentheses 1 plus 0.0575 times our 30 over 12. Or again, if you want to use that 2.5 in there. We can plug this into a graphing or scientific calculator all in one step. Parentheses are your friend when you're plugging things in. And this is going to give us a future payoff formula of $7,091.25, which is exactly what we got in part A, just a little bit less steps in here. Right, more complicated thing to plug into our calculator, but less actual steps to go through. All right, let's do one more using our future payoff formula. Kelly plans to put her graduation money into an account and leave it there for 4 years while she goes to college. She receives $750 in graduation money that she puts into an account that earns 4.25% simple interest. How much will be in Kelly's account at the end of 4 years? All right, so again, we're going to use our future payoff formula. F equals P times 1 plus RT. So I'm going to choose to work this like I did in example B, directly above here. Again, if you want to, you can go back and work through it like we did in example A. That's fine as well. Right, P, our principal, is $750. Our R, our interest rate, is 0.425. Our time is just a nice years now, so no fractions, decimals, anything to worry about. We have a time of 4 years. We're going to plug everything in here. 750 times 1 plus 0. I lost a 0 on my decimal here. I need 0.0425. That way we shifted over 2 places, not 1, as I had originally written down. So 0.0425 times our time, which is 4. Again, plug it into your calculator all at once. If you want to do it in steps, we kind of work inside to out. So do this first, then add it to 1, and then do that multiplication. F equals $877.50 after 4 years. All right, so future payoff, again, is not just our interest, but the interest plus the amount of money that was originally borrowed as our principal.